draw yourself a sine curve. Here's one that I've put on the page for you. Remember, the sine curve has those 5 easy dots, those that we remember. So 0, 1, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 2 pi. I'm going to extend back to negative pi over 2, just to give a little bit more there. Go ahead and draw a sine curve on there. Okay, so would you guys agree then that this, what you're looking at, is this a function or not? Girls in the back, what do you think? Is this a function, yes or no? How do you know this is a function? Yes, okay, I'm going to write that down. So yes, this is a function. Okay, and the reason it's a function is because it passes the vertical line test. Okay, second thing that we notice here. Does this function have an inverse? Yes or no? Wait. Well, what is it?
Oh, no.
What's this? Yeah. This does not pass. It does not pass the horizontal line test. Do you guys agree with that? Yeah, just draw any horizontal line, like say this one, for example. Look, hits there, hits there, hits there. It definitely does not pass the horizontal line test. So therefore, it does not have an inverse. Not have an inverse. So, yep, all right. So this is a problem for us because the title of this section is called the inverse sine function. So how can we even talk about the inverse sine function if this thing doesn't even have an inverse because it doesn't pass the horizontal line test? Wow. We have a problem here, right? Okay. So what we need to do, to work on here is restricting the domain. Right now, what's the domain for this sine function? The domain is all real numbers, right? All those numbers in the x-axis. Okay, good. So here's what I'm going to do. What if then, for example, I just restricted the domain to be inside this little box here, from negative pi over 2 to positive pi over 2. So what I'd like to do is draw a picture of that. Okay? Yeah, let's restrict the domain between negative pi over 2 less than x less than positive pi over 2, and draw yourself that. So it would look something like this. So if we restrict our domain,
Wait, is this a different box?
no, it's not. I'm just saying restrict the domain to give you this right here. So if we just go from here to here, this part right here, from here to here, on negative pi over 2 to positive pi over 2, and we forget about everything else, okay? Ooh, I wonder if I can do this. Do I have white? I do. Watch this. This is going to be awesome. Is that just cool to me? Okay, there we go. Sweet, look at that. No, because it was an actual PDF. Yeah. So check that out. Okay, now that I've restricted my sine curve, this is still the sine curve, right? Now that I've restricted it, y equals sine of x on this domain from negative pi over 2 to positive pi over 2, is that still a function? Yes, it's still a function. And does it pass the vertical line test? Yes. Does it pass the horizontal line test? Yes. Okay. Now that we have restricted the sine curve's function, the sine curve down from all real numbers to negative pi over 2 to positive pi over 2, then we can say, okay, then we can talk about the inverse sine. Now remember, how do you get an inverse sine graphically from a picture? What do? If this is the point pi over 2, comma 1, and this is the point negative pi over 2, comma negative 1, how would I get the graph of this? What would it be? Yeah, we would go 1, comma pi over 2, right?
Yeah.
So it would look something like this, here and then here. So my graph would look something like this. So if we then switch the x and y, switch x and y coordinates, we would get this. We would get the point 1, comma pi over 2. 1 comma pi over 2. And negative 1 comma negative pi over 2. Now I know that it looks really funky, but it ends up looking something like this. And this, I'll give you a better picture of it over here. I know this looks funky. It looks really funky, but it's just because of the way that the scale is. But this point right here, this represents the point. Whoa, craziness. This represents craziness. All we have to do is switch these points around from pi over 2 to 1. This is the point 1 comma pi over 2. Kind of hard to see, right? But like 3 pi, huh? Because I know that to get an inverse function, all you do is you change x and y coordinates. So if pi over 2 comma 1 is on the original graph, then the inverse is going to be 1 comma pi over 2.
But why is it at 1 pi over 10?
It's past that. It's past, hold on. So this is the way that we say this graph right here, this is called the sine inverse of x. Sine inverse of x. But what does that mean? So when you see that, what you say is the angle whose sine is whatever x is. So that's the English part. That's actually what it means. The angle whose sine is x. I know this is super confusing, and it's a little bit better when we do an actual example, so I'll get to that. But I want to give you some background as to why it even exists or where it even comes from. Okay? So it all starts from the fact that we have a sine curve. The domain is all real numbers. It doesn't have an inverse function until we restrict the domain. So we restrict the domain between negative pi over 2 and positive pi over 2. Then to get any inverse function, we just switch the x and y coordinates, and then we reflect that graph over the line y equals x, and you end up with this picture. Now I realize the scale's all funky. That's just because of how this program runs. But it does represent the point 1 comma pi over 2 and negative 1 negative pi over 2. So the way that we write it is like this. Y equals sine inverse of x. And that's how we say it. And it means the angle whose sine is x. That's all the background information. That's where it comes from. Does that make sense so far? It's a lot of like math background. Okay, how does this make sense in terms of what we're going to use it for? So here's the idea. So when we're doing lots of problems, we're going to find the exact value
Of what?
of these expressions. So kind of like this. So for example, part A, we're going to find the exact value for the inverse sine of root 2 over 2. All right, this looks kind of funky. And it looks really scary to some people. So the way that we say this is the inverse sine of root 2 over 2. But what does it mean? This means the angle, we are looking for the angle whose sine is root 2 over 2. Okay, that's what we're looking for. The angle whose sine is root 2 over 2. So let's think about this, all right? If we're on the unit circle for just for a moment, root 2 over 2, the sine, where is that root 2 over 2? Well, happens right here, root 2 over 2, right? And that angle will be what?
45.
Pi over 4, right? Does it happen anywhere else, you guys?
Like 4 other places.
Not 4 other places, only one other place. Where else does it happen? Yeah, it happens over here, right? Okay, at this angle here, which would be 3 pi over 4. Again, my angle is root 2 over 2, right?
Wait, are you just looking at the y coordinate?
Yes, I'm just looking at the y coordinate because I want the inverse sine. If I want inverse cosine, I'd be looking at the x coordinate, right?
Oh, the sine goes with
Sine goes with y. Yeah. So the question is, what angle will give me a sine of root 2 over 2? We found 2 of them, right? You guys told me that those angles are angle could either be pi over 4, or you told me it could be 3 pi over 4. So which one do we pick, and how do we know? Yes. The answer is we only choose pi over 4. We only choose this one. The reason being is because 3 pi over 4 is outside of the domain for inverse sine function. Okay? Remember, the domain for our inverse sine function only lives between negative pi over 2, and positive pi over 2. So therefore, when we're talking about an inverse sine function, here's pi over 2, here's negative pi over 2. Sine's going to be positive in quadrant 1, and it's going to be negative in quadrant 4. So that means inverse sine only lives between quadrant 4 and quadrant 1 because it has to stay between negative pi over 2, positive pi over 2, because that's how we set it up when we restricted our domain. So that's why the background information is important. So therefore, the inverse sine of rad 2 over 2 is only pi over 4. And so what that means is the angle whose sine is rad 2 over 2 is pi over 4. Let me give you a completely different take on this whole situation, okay? Do you guys agree that this is true? The sine of pi over 4 is root 2 over 2? You guys agree with that? So then it must be the case that the inverse sine of root 2 over 2 is pi over 4. Some people find that much easier. What do you guys think? It makes no sense. It doesn't matter to me, whichever one you want to pick. But that's the idea behind it. All right, the inverse sine of root 3 over 2. So what does this mean to us? What's the meaning behind it? What are we looking for?
The angle whose sine is root 3 over 2.
Mm-hmm. There it is. So what we're looking for is what angle will give us a sine that's equal to root 3 over 2. Now remember, we can only stay between negative pi over 2 and positive pi over 2. We can only stay here because that's where our inverse sine function, that's where the domain's been restricted. So if it is root 3 over 2, then what angle, right? What angle in quadrant 1 gives us a sine with a value of root 3 over 2? So that's what we're looking for, this angle here. What is it? And they would be pi over 3. Exactly. The domain for all inverse sine functions is between negative pi over 2 and positive pi over 2.
Oh, so that's for everything.
Yeah, it's restricted. If we go outside of that, then we don't have an inverse sine function anymore. Because of this picture, right? Remember?
Yeah.
From this picture, that's where it comes from. Yeah? All right. How about this one? A few more examples so we all get it down here. How about the inverse sine of negative 1/2? So what does that mean? That means we want an angle that lies between negative pi over 2 and positive pi over 2, whose sine is negative 1/2. Okay, well, I'm not in quadrant 1 because everything in quadrant 1 is positive, so I must be in quadrant 4 somewhere. So I'm looking for the angle whose sine is negative 1/2. So where do I have to be? Okay, now everybody always says 11 pi over 6. That means you gave me this one. That's 11 pi over 6. What's wrong with that, though? It goes outside the domain, right? So instead of giving me the positive 11 pi over 6, give me the negative coterminal angle. Good. So we want negative pi over 6. So the inverse sine of negative 1/2 is negative pi over 6. Okay? All right, take your calculators out. I want to show you something. Here we go. Clear anything that's on there? So here we go. We're going to do the inverse sine. So make sure you're in radian mode before you begin. So we want the inverse sine, so second sine, that's inverse sine of negative 0.5. Inverse sine of negative 0.5, our calculator tells us it's this funky decimal. Okay? What does that mean? That means that if we take negative pi and divide it by 6, do I get the same thing? Yes, I do. Negative pi over 6. Okay? It also works in degrees, ladies and gentlemen. So if we go to degree, it also works, but you have to interpret what that means. And the calculator, the answers, they want them in radians, but it does work. So as example, inverse sine of negative 0.5. Notice, oops, that's 8.5. Check it out. Notice it gives you a negative 30 degrees, which of course is negative pi over 6. Is that cool? You guys get it? So yes, you can do this in degrees, but your answer has to be given in radians, okay? Okay, you guys try. Here you go. Third one. We're only doing inverse sine today, okay? Here's a you try. Okay, so. Okay, give me the exact value for the inverse sine of negative root 3 over 2. And draw the picture that corresponds. Okay, here's the thought process. Many of you got this right, okay? Here's the thought process. Remember, you can only stay between negative pi over 2, which is this angle, or positive pi over 2, which is that angle. That's it. That's you're only allowed to work with. So you're looking for the angle whose sine is a negative root 3 over 2. So it's positive in quadrant 1, negative in quadrant 4, so you know you're going to be in quadrant 4. So you want the angle, which is this angle here, whose sine value is negative root 3 over 2, and that would be a negative pi over 3. Because most people will go this way, go all the way around and say, what is it, 5 pi, is it 5 pi over 3, that one? 5 pi over 3, this one, okay. That one goes outside the boundary. We're not allowed to go that way, so instead we have to find a coterminal angle, and we have to take the one that goes down because we have to stay between negative pi over 2, positive pi over 2. So therefore, we're looking at a negative pi over 3. You guys good with that? Okay, wait, before we go, last one. Okay, last one here. B. Sine inverse of 1/2.